Welcome to my class. This is chemistry class A2 subject, chemistry unit 5, topics 17b1 to different type of reaction of complex ion, reaction of cobalt and iron complex. This is the topics today. Okay, this water molecules contain 3 atoms and has 2 lone pairs of electrons. Explain why it can only act as a monodentate ligand, not as a bidentate ligand. We know water contain 2 lone pairs. This is one lone pair, one lone pair. It should should act as a bidentate ligand, 2 lone pairs, but it acts as a monodentate ligands. Why? This question answer is water has only one atom. It has oxygen, which has 2 lone pairs. So it can act. So it can form only one dative bond. If 2 atoms has 2 lone pair, like hydrogen has a lone pair, this one lone pair, say lone pair or 1 atom. For these reasons, if 2 atom has a lone pair, the 2 atom can 2 dative bond can form. But here is only 1 atom in oxygen water molecules. There is no lone pair in hydrogen. This hydrogen no lone pair. Only one hydrogen atom has lone pair. One atom has one lone pair, so one atom can form one dative bond. So oxygen can water has 2 lone pairs, but it acts as a monodentate ligand, not bidentate ligand. It form one dative bond. Okay, next question is question number 2. Write an equation for the ligand substitution reaction that occur when 4 of the ligands in the hexacoiron 3 ion are replaced by 1,2-diaminoethane En. Hexacoiron 2 3 ions are replaced by 1,2-diaminoethane. Write down this ligand substitution reaction. Okay, this question 2, this question number 1 answer now. This is question number 2 answer. Compound is hexacoiron 3 ion. Hexacoiron 3 ion. This is the hexacoa iron 3 ions. It replaced by how many? Is replaced by 1,2-diaminoethane En. Okay, 1,2-diaminoethane is bidentate ligands. It is a bidentate ligand, so it can replace 1 monodentate ligand. Water is 1 monodentate ligand, so it can replace 1 monodentate ligands. So 1 bidentate ligands can replace 2 monodentate ligand. So it will be reaction here, iron substitution reaction. So replaced 2, so it remain 4 water, and this replaced sorry, this question I have to read this again. when 4 of the ligands in the hexaqua is replaced by 4 ligands is replaced. So 4 ligands can replace by how many ethane 1 to diaminoethane. So one this 1 to diaminoethane 1 to diaminoethane can replace 2 water molecules. So to replace 4 hydrogen ligands need 2 ethene diamino ligands. So what will be here? Here it will be 4 replaced and takes to diamino 1 to diaminoethane. So 3 plus 4 water molecules. Okay, so question 2 has been done. One in a question 4 ligands must be replaced. So 4 ligand by 1 to diaminoethane. 1 to diaminoethane can replace 2 hydrogen water ligands. So 4 water ligands needed for to replace 4 water ligands need 2 1 to diaminoethane. So this is reaction replaced and take this position, and 4 water replaced here, come here. So this is the reaction. Okay, next question is topics what happened in terms of delta S entropy change system when monodentate ligands are replaced with bidentate ligands or hexadentate ligands. When a monodentate ligand is replaced by bidentate ligand and hexadentate ligands, the number of molecules of product increases. As a result, in the system entropy change in the system increases, so complex ion become stable. Look, when monodentate ligands are replaced with a bidentate and hexadentate ligands, there is a positive increase in entropy system, and so more stable metal complex ion is formed. Okay, next question. The anti-drug cisplatin has a general formula. This one, in the human body, one of the chloride ions cisplatin is replaced by 1 water molecules. Okay, this reaction occurs. Cisplatin 1 chloride ions is one of the chloride ions of cisplatin is replaced by water molecules. So the reaction occurs, this product from this. Okay, what are the oxidation numbers of platinum in these substances? Okay, these substances, what is oxidation number of platinum? Here, what is the oxidation number of platinum? Question number 2, 3, cisplatin and this water plus. This cisplatin, this product platinum NH3. Okay, here what is the oxidation number, and the product when one replaced by 1 chloride is replaced by water molecules, then what is the this product form? This product form sign is positive, plus sign. Okay, what is the oxidation number this platinum? Here this 2 is this compound is neutral, so this 0. Let this one is x. Ammonia is neutral, so 2 0, 2 0 into 2 0 0, and chloride is minus 1 minus, so 2 chloride is minus 2, and this is the neutral compound, so it equal to 0. So here x equal to plus 2. Okay, oxidation number is plus 2. In this compound, let platinum x, ammonia neutral, so 0, 2 0 into 0. Chloride is minus 1 minus, so 1 minus, water is neutral, so 0 equal to, this is plus charge, plus 1 charge, so plus 1 charge. So what will be oxidation number? Oxidation number is plus 1, that means plus 2. So in these two compounds, here platinum oxidation number is plus 2, here platinum oxidation number is plus 2. So this question answer is B option is plus 2 plus 2. B option is correct answer. Okay. What are the oxidation number of platinum in these substances, here and here? So plus 2 plus 2. So option B is correct. Type of reactions. In ligands, there are 4 types reactions occur. 4 main types of reaction can occur: redox reaction, disprotonation reaction, ligand exchange reaction, coordination number change. Okay, redox reaction, the oxidation number of the transition metal ions changes. The in a redox reaction, oxidation number of the transition metal ions changes. Deprotonation reaction, one or more of the ligands gains or losses hydrogen ions. Deprotonation reaction, one or more of the ligands gains or losses hydrogen ions. In a deprotonation reaction, ligands gains or loses hydrogen ion. Here oxidation number of transition metals increases. A ligand exchange reaction, one or more of the ligands around the transition metal ion is replaced by different ligands. Coordination number change means number of ligands change. Coordination number change. So there are 4 types of reaction occurring complex ions. Redox, here oxidation number of transition metals ions changes. Deprotonation reaction, ligands either loss or gains hydrogen ion or proton. Ligand exchange reaction, one or more ligands around the central transition metal ions is replaced by the different ligands. Coordination number change, this number of ligands change. So we'll see the change in oxidation number. First one, in aqueous solution contain iron 2 ions, is a pale green color, iron 2 ions, but when it is exposed to air, it gradually turns yellow or brown. The oxidation number of iron increases from plus 2 to plus 3. This type of number, the type and number of ligands remain unchanged in this oxidation number. The type and number of ligands remain unchanged. This the ligand number of ligands remain unchanged, but oxidation number changes. This is oxidation number plus 2, oxidation number plus 3. So oxidation number changes. So but number of ligands remain same. Here is the number of ligand is 6, number of ligand is 6. Only change in oxidation number. In oxidation number change reaction, change only oxidation number. Equation are not usually written for oxidation reaction. Okay. We don't need to write equation for oxidation reaction. This is uh, iron 2 sulfate. Now it oxidation number changes. It become iron 3 sulfate. This is the pale green. This compound is brown color, iron 2 sulfate. Here is a oxidation number changes. So oxidation number change reaction, oxidation change reaction, redox reaction. Okay, this is the redox reaction. Okay, now say reaction is formation of tetraamino diaqua copper 2 ion, deprotonation and ligand exchange reaction we see here. So here this is you may understand looking this ligand replaced water and form hydroxo tetraaqua dihydroxo copper 2 copper ion. It may use looking this ligand exchange reaction, but it is not ligand exchange reaction. In this reaction, what happens? Consider the reaction that occur when aqueous sodium hydroxide is added. This is a hydroxide is added to copper 2 sulfate solution. The observation is that pale blue solution form a blue precipitate. This blue solution, pale blue solution form blue precipitate. This is the blue precipitate. The equation for this reaction, you may say understood this reaction is ligand exchange reaction, but it is not actually ligand substitution or ligand exchange reaction. You might think this is a ligand substitution reaction, that 2 hydroxide ion have replaced 2 water molecules. In fact, it is a deprotonation reaction, because the 2 hydroxide ion replaced here 2 hydroxide ion replaced 2 hydrogen ions from here, and now it becomes 2 hydrogen molecules. So it replaced 2 hydrogen atoms. So deprotonation, dehydrogenation, hydrogen replaced. So deprotonation reaction occurs. Here the 2 hydroxide ion have removed hydrogen ion from 2 water ligands and converted them into water molecules. The 2 water ligands have lost hydrogen ions and now hydroxide ions. Now it lost 2 water molecules, lost 2 hydrogen ion. Now it become hydroxide ion, and 4 water molecules remain same. So this is the deprotonation reaction. Now here is when aqueous ammonia is added to the blue precipitate formed here, it dissolved to form a deep blue solution. Form. The equation is this. This is the ligand exchange reaction, because this 4 ammonia replaced 4 water molecules and takes this position. So this is the ligand exchange reaction. 4 ammonia replaced 4 water molecules and take this position. So this is the ligand exchange reaction. Sorry, 4 ammonia replaced 4 ammonia replaced 2 hydroxide ions and 2 water ligands and form this compound. This ligand exchange reaction, 4 ammonia molecule replaced 2 water molecules and 2 hydroxide ions. So here this reaction occur. In this reaction, before this reaction, this color was blue precipitate. Now it become deep blue solution. This is deep blue solution. At the beginning, the reaction was A, B, C. Okay, what is A and B, C? A is this is the this is pale blue solution. This is actually hexa aqua copper 2 ions. When deprotonation reaction occur, this hydroxide ion replace two hydrogen ions and form diamino tetra diamino complex. Sorry. This is at first this is the hexaqua copper 2 sulfate solution. This pale blue solution. When hydroxide and sodium hydroxide is added, alkali sodium hydroxide is added here, hydroxide ion replaced hydrogen ion from ligands and form tetra aqua 2 dihydroxo copper 2 sulfate precipitate. This is the precipitate. This reaction is 2. This color is blue precipitate. When excess ammonia is added, this here is a replacement reaction occur. Ligand exchange reaction occur. Two water molecules two water molecules and two hydroxide ions is replaced by ammonium and form deep solution, deep blue solution. This is the reaction. This from the pale blue solution becomes pale blue precipitate. This is the reaction occur. Deprotonation reaction, and from deprotonation reaction, when excess ammonia added, so it form tetraamino diaqua copper 2 sulfate. This is reaction. This product is formed by the ligand exchange reaction. So here formation of change in coordination number. Now this is hexa aqua copper 2 ions, 4 chloride is replaced. Now coordination number. Now coordination number is number of ligands. This changes. Number of ligands. This metal ion is 6. Here is a 4. So coordination number changes. So this reaction is called coordination number. But charge is the reaction always involves change of the ligand as well as change in the coordination number. The reaction always involve a change of ligand as well as change in coordination number. This reaction occur changes coordination number change of ligand occur as well as change in coordination number. Good example, the reaction between copper 2 sulfate solution and concentrated hydrochloric acid. When acid is added slowly and continuously, the color gradually changes from blue, this is blue, to green, finally to yellow. The state symbol always aqueous have been left for clarity. We can see that all 6 ligands have been replaced by 4 chloride ions, and this reaction is also an example of change in coordination number from 6 to 4. Note that the charge on the complex ion has changed from +2 to 2. Has been no change in coordination number. This is coordination number, no change. Do you know what is coordination number? This coordination number copper is 2+. This copper also 2+. Coordination number do not change. But here number of ligands changes. Ligands is number 6, now ligand number 4. So this is the change in coordination number. Define amphoteric. An amphoteric compound is a molecule or ion that can act as a both acid and bases. Amphoteric. Amphoteric means, look, amphoteric, define amphoteric. An amphoteric compound is a molecule or ions that act as a both acid or base. It acts as a sometimes it acts as a acid, sometimes it acts as a both base. So those compounds which act as a acid and act as a base, they are amphoteric compound. Now we see the amphoteric compounds. Amphoteric hydroxide. We have already seen that hydrated transition metal ion can be deprotonated by adding a base deprotonated aqueous sodium hydroxide to form precipitate of metal hydroxide. For example, now chromium 3 hydroxide is precipitate from aqueous solution containing chromium ions. Like this is what happened there. Here this 3 hydroxide ions replaced 1 water, or 3 hydroxide ion here replaced 3 hydrogen atoms, ions from water molecules. So 3 hydroxide ion is formed and 3 water remaining. From 3 hydrogen find these 3 hydroxide become 3 water molecules. Here this chromium react with base, so chromium here act as a acid. Okay, when excess sodium hydroxide is added to the precipitate, further deprotonation reaction take place. This form and again replaced this hydroxide replaced 3 hydrogen atoms from this green solution. From green precipitate now become green solution. In this reaction, chromium 2 3 hydroxide as acting as an acid, since it is reacting with a base. Here chromium 3 hydroxide acting as a acid because it react with a base. This is a base. So chromium 3 hydroxide here act as a acid. Now chromium 2 3 hydroxide also base. It can react with acid. Now this chromium 2 hydroxide react to 3 hydrogen ions from this compound. So it is acid, hydrogen plus ion acid. It react this compound react with acid. So this compound now act as a acid. So it will be base. So this compound act as a base. Here this compound act as a acid. Here now this compound act as a base. So we can say the hydroxide ion, hydroxide act as a both acid and base. So it is called amphoteric hydroxide. This is an example of amphoteric behavior of hydroxide. Okay, problem solved. This equation for the reaction of transition metal ions is explain which of the 4 main types reaction occur. Reaction are illustrated by this equation. This is look, this is thiocyanate ion replaced thiocyanate is in 1 negative ions. So what is it is looking ligand exchange reaction. 1 water molecules is replaced by 1 thiocyanate. Okay, this is the ligand exchange reaction. Is it redox reaction? In a redox reaction, oxidation number changes. It is at first we find this is ligand exchange reaction as one thiocyanate replace one water molecules. So one water molecule replaced. Is it coordination number redox reaction? Is it redox reaction? In redox reaction, in redox reaction, oxidation number changes. Look, what is the oxidation number? Iron oxidation number is 3. Now what is oxidation number here? Iron let X, iron oxidation number X, thiocyanate -1, water neutral 0. So X equal to +2. Is it oxidation number change? Look, iron. Hexaco. Okay, S-cyanide. Here is the oxidation number iron is +3, because it's neutral 0. This +3. Now here oxidation number thiocyanate 1 replace. This is +2. Here let X cyanide -1 cyanide is this 0, 5 neutral 0 +2. So oxidation number is remains same, +3. So there is no redox reaction. Oxidation number is same, charge changes, but oxidation number remains same. Charge changes, +3 +2, but oxidation number of iron +3, and here also +3. So oxidation number no change, so there is no redox reaction. We can check this is protonation reaction. No, there is no deprotonation reaction. No hydrogen ions is replaced by this one. This is a ligand exchange reaction only. Okay, this is only ligand exchange reaction. This one ligand is replaced this water molecules and take this position, and now this 5 waters and this take position. So it is a ligand exchange reaction only. This question is only so here explain which of the 4 main types of reaction are illustrated by this equation. So this is the ligand exchange reaction only. Okay, now question number 2. Complex ion hexacoa cobalt 2 is converted hexamino cobalt 3. Explain which type of reaction occurs. This is at first we see this ligand exchange. So ligand exchange reaction. Here coordination number also change. So redox reaction occur. This coordination number +2. Coordination number +2. Here the coordination number is +3. So coordinate redox reaction occur. Is it occurs here? This is coordination number. What is no oxidation number change? Oxidation number, this cobalt is cobalt, let cobalt X plus 6 water molecules neutral, 0 equal to plus 2. So X 0 plus 2 means plus 2. Here this let X neutral, ammonia neutral, so 0 plus 3. So X equal to plus 3, here X equal to plus 2. So coordination number change. Oxidation number change. Oxidation number change. Its cobalt oxidation number is plus 2. Here cobalt oxidation number is plus 3. Coordination number change. So this is the redox reaction. Here ligand change. Ligands exchange occurs. So ligand substitution reaction or ligand exchange reaction occurs. So two types reaction occurs. Another is it protonation? No, this is here no protonation reaction occur. And another is coordination number change. No, this is coordination number is 6. This coordination number is 6. No coordination number 6 changes. So two types reaction occur: ligand exchange reactions and redox reaction. Okay. Thank you for joining. Thank you for watching my video.